We've just discovered a galaxy that, quite frankly, shouldn't even exist, and it's turning everything we thought we knew about physics upside down. When this galaxy was shining, the universe was practically a newborn. Imagine finding a skyscraper in a world where there were only mud huts. That's the scale of this discovery. And here's the most insane part. This ancient galaxy is blazing with extreme intensity. According to current theories, the first galaxies should be small and faint. But this one is producing stars at a mind-blowing speed, all within a space 400 times smaller than our Milky Way. And it gets crazier. Chemical analysis of this galaxy shows a pattern similar to that found in ancient star clusters inside our own galaxy. In other words, it was already creating complex elements when the universe was still in its cosmic infancy. The result? Scientists around the world are literally rewriting science textbooks. We're not just looking at one of the oldest galaxies ever found. We're seeing a primordial universe that's way more chaotic, fast-paced, and ambitious than anyone ever imagined. Seriously, this is head-exploding stuff. The light from this galaxy, named MOMZ14, started its journey through space when the universe was only about 280 million years old. For perspective, the universe today is 13.8 billion years old. And what made this discovery possible? Once again, the powerful James Webb Space Telescope, which has just broken its own record. Webb's observations are forcing astronomers to rethink their models of early galaxy formation. Now stop and think for a second. This light started its journey long before our solar system even existed, long before Earth formed, and long before any known life took shape. And by the way, this isn't the first time Webb has left the scientific community stunned. Since it began operations in 2022, this telescope has been consistently discovering galaxies that are older and brighter than anyone expected. It's almost like every time scientists think they've hit the limit, Webb shows up and says, "Hold my beer," and delivers another impossible discovery. Now, a common question in the comments. How do we even know the age of such distant galaxies? The answer lies in one of astronomy's most fascinating concepts, redshift. In simple terms, the universe is expanding. Literally, space itself is stretching. And as light travels through this stretching space, it also stretches, shifting to longer, redder wavelengths. This phenomenon acts like a cosmic timestamp. The higher the redshift, the farther away and older the source of that light is. The galaxy MOMZ14 has a redshift of 14.44, just edging out the previous record holder. But in astronomy, small numerical differences represent mind-blowing distances and times. We're talking about seeing millions of years deeper into the universe's childhood. Now here's the big problem. Our best models of how the universe evolved didn't predict a galaxy this bright at this point in cosmic history. The first stars were expected to be huge, short-lived giants that burned out quickly. The first galaxies were supposed to be small, faint, and rare. We thought we'd find just a handful of these ancient cosmic lighthouses, not the growing collection of ancient galaxies that Webb keeps revealing. But MOMZ14 is incredibly luminous for its age. It's generating light at a rate that indicates star formation happening at full throttle, way faster than current models said was possible back then. It's like stumbling upon a fully grown oak tree in a field where there should only be seedlings. Plus, the galaxy is super compact, just 240 light-years across, making it about 400 times smaller than the Milky Way. But don't be fooled by its size. Its mass is comparable to the small Magellanic Cloud, one of our galaxy's satellite galaxies. And there's another twist. MOMZ14's chemical composition reveals even more mysteries. When astronomers analyzed the light from this galaxy, they found something totally unexpected. It's rich in nitrogen compared to carbon. That might not sound like a big deal, but to astronomers, it's like finding a fingerprint at a cosmic crime scene. This chemical signature is strikingly similar to what we see in globular clusters, which are dense swarms of stars containing thousands to millions of stars, orbiting galaxies like ours, and existing for over 12 billion years. These clusters are like time capsules, preserving the chemistry of the early universe. So why is this exciting? because MOMZ14 seems to carry a chemical accent that echoes these ancient star clusters. It's as if, in different corners of the universe and across vast stretches of time, nature kept repeating the same cosmic recipe. This suggests that the basic ingredients for star and galaxy formation were already in place far earlier than we thought. Maybe the universe didn't waste time figuring out how to make stars. Maybe it sprinted right into it. And the implications? Massive. This discovery hints that fundamental patterns in stellar chemistry started repeating across the cosmos, even in the universe's earliest chapters. The fact that we're seeing so many bright, mature galaxies in the early universe implies that galaxy formation started sooner and advanced way faster than we ever believed. This has a direct impact on our understanding of dark matter, black holes, and how large cosmic structures evolved. Some scientists are already proposing that we may need to rethink how quickly matter could clump together in the early universe, or how fast the first black holes could grow and seed these early galaxies. And what's next? The quest for even older, more distant galaxies is just getting started. The researchers behind this discovery made it clear. Redshifts that once seemed unimaginable are now within reach. We're getting closer to observing the era of the very first stars. The upcoming Nancy Grace Roman Space Telescope, scheduled for launch in May 2027, will offer an even wider field of view than Webb, potentially allowing us to discover hundreds or even thousands of these ancient galaxies. But until then, Webb's mission continues. It's still on the hunt, searching for galaxies with even higher redshifts. And given its track record, it's only a matter of time before MOMZ14 loses its title. The most amazing part? Every new discovery helps us piece together the puzzle of cosmic evolution. We're not just spotting random ancient galaxies. We're mapping an entire era of cosmic history that was completely invisible to us until now. And here we are, in 2025, casually looking at light that began its journey when the universe was barely out of cosmic diapers. So's key takeaways. First, the early universe was way more mature and active than we predicted. Second, the processes of star and galaxy formation were already running full speed, much earlier than expected. Third, we're just getting started. The era of the first stars and galaxies is finally within our observational reach. But here's what blows my mind the most. Every single photon from MOMZ14 that hits Webb's mirrors has traveled through an unimaginable stretch of space and time. These aren't just particles of light, they're messengers from the dawn of time, carrying information about a universe that existed when it was just 2% of its current age. And you? What do you think this means for our understanding of how life may have emerged in the universe? Could these hyperactive early galaxies have been the first cosmic nurseries of life's building blocks? Let me know your thoughts in the comments below. And if discoveries like this blow your mind as much as they blow ours, make sure to hit that subscribe button and turn on notifications, because this cosmic journey is just getting started.